Hi guys, welcome to today's lesson. We'll be looking a little bit more in depth of quadratic equations, and we're looking at the roots of a quadratic equation. So far we know that all quadratic equations are in the form of y is equal to ax squared plus bx plus c. Okay, where the a is in front of the x squared, the b is in front of the x, and the c is that plus number, or that number on the end there. Now we've used this for things like, I guess, the quadratic formula. We've used it also for the axis of symmetry. And it can be used for lots of different places, but it is the general form of a quadratic function. Okay, something else that I have spoken about before is that when you solve a quadratic equation, okay, to find the x-intercepts, what you're actually finding is not just the x-intercepts, but we are finding the roots of the equation, or the x-intercepts are called the roots of an equation. Okay, for example, you might have the function f of x is equal to x squared plus 3x plus 2, where if I was asked to solve that, we'd let y equal 0, or f of x equals 0. We'd get x squared plus 3x plus 2 equals 0, which we've now formed a quadratic equation. We then solve it. In this case, I can do it via factorizing x plus 2x plus 1. Now I can finally solve it to get x is equal to -2, x is equal to -1. And what happens, this -2, -1, these are called the roots of my equation. Okay, the roots of my equation. Now that's the first part that we're looking at. The second thing we spoke about is what happens when you have two roots. When you have two roots of an equation, that means you have, in theory, not in theory, you have two x-intercepts. So what's going to happen is you'll get a question or a parabola that goes through the x-axis twice. Okay? If you have simply one root, what do you think might happen then? Hopefully you might recognize that my parabola will actually just sit on top of that x-axis. That means that when you're looking at it, as opposed to the first one where it cut the x-axis in two places because it had two roots, in this case it only touches the x-axis in one place. Therefore it has one root. So what happens if you think you have no roots? Well, some people think, well, because there are no roots, it means that the parabola can't exist. That's actually incorrect. Okay, it certainly does exist. What happens, it exists completely above that x-axis. Okay, what we actually say, we say it has no solution. Okay, but just means that it sits completely up above the x-axis. It might also be definitely below the x-axis also. Okay, likewise you could have a parabola that hits at one spot, which is a negative, or hits in two places as such. You can see clearly on both those that's still got two roots, that's still got one root, and that obviously has no roots. Okay, so these have different names, these graphs. Okay, these do have different names which we want to look at. The first one where it says has two roots, this is what we call the indefinite. An indefinite function, okay, which means it sometimes gives a positive or a negative, okay, and it cuts the x-axis in two different places. That's an indefinite. We also have the function that has no intercepts. Okay, so this one here, we would call this one a positive definite. Well, we'll call it definite because it's definitely above the x-axis and it's a positive. So likewise, this one here might be called the negative definite because it's definitely below the x-axis there. Okay, so what type of questions might they ask us? I'm going to give you two different questions that they can, I guess, pose. The first of all might say the following: sketch the graph y is equal to x squared take away 4. And that might say, how many roots does the equation have? The equation x squared minus 4 equals 0 have. Okay, so the first part of it is pretty much like we were doing the last with the last two lessons, where we're simply just graphing x squared minus 4. Now x squared minus 4 is a bit of an easy one, because we should recognize that it's going to go through negative 4. It's a positive graph, so we're going through like that, where my axis of symmetry goes directly down there. Now obviously I want to find out what my x-intercepts are, so I'm going to put 0 is equal to x squared minus 4. X squared is equal to positive 4 by adding over there. X equals plus or minus 2. So I'm going to put negative 2 there. I'm going to put positive 2 there. I've now got every bit of information there, including my turning point of 0, negative 4. I've now sketched my graph. Okay, it then says how many roots does the equation have? Well, clearly you can see there it cuts the x-axis twice, therefore it has 2 roots. We can see that though from our solution there. Okay, so that's the very first question. Sketch it, how many roots does it have? Very straightforward. Okay, what about a bit more challenging question? Okay, we're going to have show that negative 3x squared plus x minus 1 is less than 0 for all x, hence showing it is negative definite. Okay, so basically if it's saying that we want to show it's less than 0 for all x, and then hence showing that it's going to be negative definite. So negative definite is going to mean it's going to be a negative parabola. Okay, it's an unhappy face parabola, and it's going to be completely underneath, because it's definitely on one side of that x-axis. Obviously, if it was negative up there, at some point it's going to come down and cross it, giving it two roots. That's not going to work. So I need to show it's going to be having no solutions, basically, and that it's going to be down there. So I need to sketch it first of all. So if I have a look at here, I've got the function of f of x is equal to negative 3x squared plus x minus 1. We know that it's going to go through the point negative 1. I already know that I'm proving that it's negative definite. Okay, so what I might do, I might just show, to double sure, I'm going to chuck it into the quadratic form just to show that it can't have any roots. So I'm going to do minus b, which is negative 1, plus or minus the square root of b squared, of b squared minus 4 times a times c, all over 2a. So negative 1 plus or minus the square root, well, it's going to give me 1. Sorry about that. I just got a little bit stuck there, and I realized that I hadn't put my negative in front of the 1 there. Okay, because remember that's negative 1 there. Okay, so I've got 1 square, which is 1. Then we've got negative 4 times negative 3 is positive 12 times negative 1 is negative 12. All over 2 times negative 1. Which we can automatically see now that that square root is going to be square root of negative 11, which can't happen. Okay, therefore no solutions. So therefore no solutions or no roots. The other thing I want to do, because I want to sketch it, we would like to have my axis of symmetry as well as another point. So let's do an axis of symmetry as well. So let's do x equals negative b over 2a. So x equals negative b, so negative 1, over 2 times negative 3, which gives me negative 1 over negative 6, which gives me 1/6. Okay, so my axis of symmetry, let's say that's going to be positive 1 there. 1/6 is going to be sort of here. Now, my axis of symmetry is going to be there, so it can only go like that, I guess. Now, of course, what you could then do is sub that back in to get your y value, and then you exactly know what your y value is going to be. But I'm not going to bother, because at the moment all I'm wanting to show that it is negative definite, or it's less than 0. So therefore it is less than 0, as it is a negative definite function, as it's under the x-axis, or something along that lines. So as long as you can show that it's going to be underneath that x-axis and it is a negative parabola, you're going to show that it is a negative definite. Something I'm going to just talk about very briefly, and this will certainly be coming into the next lesson, is you notice that this little bit underneath the square root sign, okay, which we know is the b squared minus 4ac, is really, really, really important. Because what you notice that when I put that number there, if that's a negative number, we automatically know that it has no solution, okay? Because we can't square root a negative number. Now, often we refer this to delta, okay? And we say if delta is less than 0, we have no roots. We say if delta is equal to 0, then we have 1 root. And then if delta is greater than 0, we have 2 roots. Which basically means that if this number is going to be 0, then this is going to be a perfect square, perfect number. It means it's going to only have one solution, because you're doing minus 1 over whatever's on the bottom. Not plus or minus, because plus or minus 0 cancels out. So you're only going to have one solution. Whereas if it's greater than 0, when you do the plus number and then you do the minus number, you come up with 2 different answers. You get 2 roots. That's our lead in to our very next lesson, where we're looking at what we call delta, or in better terms, the discriminant, because it discriminates between no roots, 1 root, and 2 roots. It's very, very effective. But look, a couple of different types of questions there that you can get. Once again, guys, for my 2-unit students, that is referring to exercise 9.3 on page 356. Get amongst it. Make sure you get those questions answered. Have a crack at it. Any problems, let me know. This stuff is pretty important. Cheers.